distribution X is approximated by B, N, and P. N represents the number of trials. P is the probability of success. So the first question is asking us, what is the probability that X is less than or equal to 10? So that means, let's write down what this is actually saying. It's saying that if we are doing this trial 20 times, what is the probability that we will be successful 10 times or less? That's essentially what it's saying. So that's essentially kind of asking us to find out the probability of X equaling to 0, add probability of X equaling to 1, all the way up to and including probability of X equaling to 10. So that's what probability of X less than or equal to 10 is. Now, if we did that, we could do this individually, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we could use the probability formula that we looked at here, this, for each of those cases, 0, 1, 2, all the way up to 10, and then add them all together. That's one way of working that out, but that would take a while. So there's a quicker way of doing this, which is using the binomial CD, which we're going to look at now, because it's everything up to and including 10. And how we do these questions is always by starting off with a number line to represent the number of trials. So the trials goes all the way from 0, all the way up to 20. So that's essentially just comes from that number there, the 20. 0, you can have 0 successes. Okay, so this is what how many successes we have. Sorry, X. Okay, N is 20 there. So X could be 0 all the way up to 20. Now we are interested in X going up to and including 10. So I'm going to put 10 somewhere. It doesn't really matter where. I'm interested in that number 10. And I want everything from 10 all the way down to 0. Now, the calculator and the table only works out everything to the left-hand side of this number line. It only works out this side here. So I'll make a note here, calculator and tables only does this calculation. So in this case, it's going to be easy because we can just use our calculator and or tables to work this side out. But if it wanted us to work out the other side, we can work out the other side, but we'll just write down the number on the other side of that line. It will be 11. So that side, you would have to do manually by doing 1 minus the left-hand side, because we know all the outcomes add up to 1, the probability. So if we know the left-hand side, we can work out the right-hand side. So the calculator does this. Always remember that. So what is this? Well, this is the probability of X being less than or equal to 10. So what's going to be on the right-hand side? It will be probability of X being greater than or equal to 11. And how would we work that out? It would be 1 minus the probability of X being less than or equal to 10. So always start off with the number line. I can't emphasize how important it is to start off with this number line. So let's go and take a look at how we would then use our, well, let's take a look at the calculator, because there is a function on the calculator that enables us to do that. So if you get your calculators out here and go to menu and then scroll until you come to distribution, which is function 7. Click on 7, and then it gives you the option to choose a few things. It's got 1, 2, 3, and 4, normal PD, normal CD, inverse normal, binomial PD. But click down again on the scroll, and then it will bring you 3 more options: binomial CD, Poisson PD, and Poisson CD. We want to select binomial CD because we're doing cumulative. We're doing more than one value for X. We're looking at 0 up to and including 10. So click on that function and then select variable. Okay, so then your calculator display should give you the following options. It will say binomial CD. So this is what's on your calculator. It says binomial CD, and it gives you the option to write down what you're going to be using for X, what you're going to be using for N, and what your P of P is. So X, remember the calculator does only up to and including that number. So binomial CD, it will, the X here that we're using is this value here. Okay, it's the one that it goes up to and including. So we're going to use 10 here. N is the total number of trials that we have, and that's 20. Okay, that comes from our binomial distribution, the number of trials. Yeah. P is the probability of success, which is also coming from our binomial distribution. And for this particular question, we can see here 20, 0.35 is P. So I'm going to go and put 0.35 here. And when you put those values into your calculator and you then press equals, what it will give you is the answer for probability of X being less than or equal to 10. Press equals, I think you might have to press it twice, and then it gives you an answer of 0.9468. Always do your working out to 4 significant figures when we are working with probabilities here. Okay, keep that line going down the middle, because what we've worked out is for the left hand side. So suppose then we wanted the right hand side, it will be probability of X being greater than or equal to 11 would have been 1 minus this probability that we've just worked out if we wanted the right hand side. So this is a very nice layout for doing probability distribution questions. Starting off with the number line, splitting it down. The left hand side is what the calculator or the tables work out. The right hand side is not. Okay, so we've done part A. I'm going to go and take a look at, for instance, if I wanted to find out what probability of X is greater than 6. Well, let's see how we would do that. Well, again, I'd start off with my number line, 0 all the way to 20 is what X is. But I'm interested in probability of X is greater than 6. So I'm going to put 6 here. Now, greater than 6, it doesn't have greater than or equal to sign. So it means I want not 6 included, but what's after 6. So 7 up to 20. I want that. So this is where I would draw my split. Now, calculator doesn't work out the right-hand side. It only works out the left-hand side. So I'll highlight that. That will be my calculator side. So the calculator will work out probability of X less than or equal to 6. And what's on the right-hand side is probability of X greater than or equal to 7, which is exactly the same as probability of X is greater than 6, not including it. Okay, it's the same thing. So I'll write that down on the right-hand side. Now, I can't go and work this out straight away. In order to work this out, I need to do 1 minus probability of X is less than or equal to 6, i.e. what's on the left-hand side. Calculator does this left-hand side. So we're going to go and use our calculator now. And in our calculator, again, we go and put the same inputs. The inputs that it lets us put in is X, N, and P. This time for X, we're going to use 6. For N, it still remains 20 trials, and probability of success is still 0.35. When you do that, it gives us the probability of X being less than or equal to 6. So go back to your calculator and change the value of 6, X to 6. Everything else remains the 7. Same, and so this gives us 0.4166. Now that we've got that, we can work out the probability of X greater than 6 is equal to 1 minus 0.4166. Okay, so if we go and work that out, 1 minus 0.4166, and that gives us 0.5834. Okay, so always start off with this number line. Very important, I can't emphasize. I'm going to look at one more here. The probability of X equaling to 5, we're going to go and take a look at that. Now, the probability of X equaling to 5 is just, again, if I start off with my number line 0 all the way up to 20 trials, we're only looking at 5. So we're only looking at this particular value. We're not looking at left-hand side, right-hand side, one value here. So this is where you could go and use the one of two things. You can use your calculation, which is NCR, probability of success to the power of R times 1 minus P, which is the probability of failure to the power of N minus R. Or you can go and use your binomial PD function on the calculator. Okay. How would we find the binomial PD function? Well, that's by using, again, go and find distribution, which is 7, but this time you're selecting binomial PD, which is option 4. Again, select variable, and when you do that, it gives you the following options: X, N, P for the input. For this time, X, you're going to put 5. For N, it's 20 trials. Probability of success is still 0.35. And this time, what it gives you is not probability of X less than or equal to 5. It gives you instead probability of X equaling to 5 only. And when you put those values in, it will give you 0.1272 to 4 significant figures. If I did it using the manual way, it would be 20C. We want it to be successful only 5 times. So 20C5. Probability is 0.35, probability of success to the power of 5 times 0.65 is the probability of failure, i.e. 1 minus 0.35 to the power of 15, because we want it to fail 15 times and be successful 5 times. The 5 and the 15 should add up to 20. Okay, as you can see there. And if you did that calculation, it would give you exactly the same thing, 0.1272. Okay. So I have a preference. I tend to go and use the binomial PD on the calculator. It's just easier because that's why you've got the calculator there. So that's how you find out one particular value. Going back to the question, last thing that we're going to look at is this bit here, which is how do you find the probability of it being between two things, 2 to 7, 2 to 7 inclusive. So again, start off with a number line. Okay, so I'm going to start off with my number line here, 0, ... all the way to 20. This is what X is. I'm interested in everything from 2 to 7 inclusive. So I'm interested in that. I'm just going to highlight what I'm interested in. Okay. Now, in order to find that, remember the calculator doesn't do middle bits. It does everything to the left of it. So what I'm going to do is I'm going to put a line here. I'm going to work out everything to the left of 7. And I'm going to then work out everything to the left of the number before 2. I'm going to put this number here, 1. Okay. So what I'm going to do is to work out the probability of X being less than or equal to 7 and greater than or equal to 2, which is what my question is. I will do everything to the left of 7, 7 inclusive, so all of that, which is probability of X less than or equal to 7. And calculator does do the left-hand side, remember. And I'm going to minus everything to the left of probability of X being less than or equal to 1. So I'm going to do all of this. Okay. To get that, I'm going to do all of that minus all of that. And the calculator does do the left-hand side, as we know. Okay, so you've got kind of two things to do. So how do we find this? Less than or equal to. The calculator does everything for less than or equal to. How would we work this out? Well, you need to go to your calculator input, X, N, P. X is 7, N is 20 trials, probability of success is 0.35. And this will give us what probability of X is less than or equal to 7 is. Okay. So again, go to your distribution. This time, remember, you're using CD because you want everything less than or equal to 7. So go down to your calculator function and select CD, variable. X is 7 this time, N is 20, 0.35. So this gives us 0.6010. And then do the same thing for this here, probability of X less than or equal to 1. Again, X, N, P. X is 1 this time, N is still 20 trials, probability of success is 0.35. This will give us the probability of X being less than or equal to 1 as equal to, okay, so let's go and put that in. And that gives us 0.002133, again, to 4 significant figures. Now notice how I'm going to work out the answer. It's going to be this probability take away the other one, as we've shown earlier there. So what is that? Well, it's 0.6010 minus 0.002133. Okay. And that gives us 0.5989 to 4 significant figures.